Hello everyone, in this video I will introduce our paper Unsupervised Image Denoising in Real-World Scenarios while Self-Collaboration Parallel Generative Adversarial Branches. We compare the latest supervised and unsupervised denoising methods, and we can conclude that the supervised-based method outperforms the unsupervised one on both as PSNR and SSRM. So what is the reason that causes this phenomenon? The answer is that there is a gap between the synthesized noisy image and the real noisy image. In our work, we are motivated to surpass the performance limitations of conventional GAN-based unsupervised frameworks without significantly modifying the existing structure or increasing the computational complexity of denoisers. Our contributions can be briefly concluded as three main points. Firstly, we designed a novel filter-guided synthetic noisy image generator with the NE module to synthesize clean image pairs. Secondly, we propose an effective parallel generative adversarial branches framework with unpaired synthesis constraints as our baseline. At last, we are the first to propose the SC strategy. It makes the GAN-based denoising system work much better without making it harder to use. And here are our methods. First, we designed the filter-guided synthetic noisy image generator. If the noisy and clean images are fed directly to the generator, it should focus on the noise information of the noisy image. We designed it to reduce the generator's workload of learning out the extra information. Less burden, better performance. Next, this is the architecture of our proposed SCPGAB net framework. It consists of two branches, unpaired synthesis to self-synthesis, and self-synthesis to unpaired synthesis. Each branch contains a self-collaborative operation that involves a noise extraction module NE and a denoiser DN. The NE module extracts noise from the noisy image, and the DN removes the noise from the noisy image to generate a clean image. To show more detail, here is the SC strategy. In NE, K denotes the number of iterations. The iterative process results in a series of increasing powerful denoisers. We conducted a lot of experiments. This figure shows the experimental part of our comparison with other baselines on multiple tested datasets, and we can see that our method has a large advantage over all previous unsupervised methods. This figure shows the experimental parts of our ablation experiment, which validates the effectiveness of our method and module. This graph validates the effectiveness of the SC strategy. The upper part shows the results of SCPGAB-net on the SIDD benchmark. The lower part displays the improvement achieved in each iteration. Last, evaluate the generality and transferability of our approach. We apply the proposed S strategy to several classical and the latest denoising networks, including DNCNN, UNet, and so on. Consequently, the results demonstrate that our S strategy has strong transferability and can be potentially applied to other unsupervised denoising methods. For the subsequent work, we will extend it to the recovery task version in order to better validate the generalization of SC. Thank you for your interest in our work and welcome your comment. Thank you for listening.